Hello guys, welcome you all once again for this end-to-end session of AML where you guys gonna learn everything from the scratch of how to load the model, how to load the data, how to interact with the data, how to fine-tune the data, what is data, and then we will be moving on to ML, AI model creation and everything. Okay, so guys, we are just enjoying every day. Okay, we are just enjoying and learning every day. Hope you guys are doing the same thing. And before coming for this session, make sure that you guys have a perfect understanding of whatever we have done before. So please make sure that you guys are watching all the previous session videos so that this can be very you guys can able to understand these sessions because it will be the continuation of whatever the things that we have done previously. Okay, so make sure that you guys watched all the previous session video so to have a perfect understanding of what we are talking now. Okay, so hope I think last session is a session where we guys have jumped into the machine learning part, right? Before that we have worked on all the things like how to just load the data, how to fine tune the data, how to do EDA on the data on top of data, and then we have just go through the bit of SQL, Python, or and then we have just visualize some things. Yeah, these things are we have done from the previous session. We are moving into the step ahead into machine learning. Okay, where you guys gonna see the combination of theory and coding part. Okay, I'm very much interested. Okay, I hope the same you guys are. Okay, so yeah, today we gonna learn a theory concept like what is supervised learning. I think most of you guys are already know. Okay, just we gonna brush up the things and we gonna dive into their algorithms which are inside it, and then the coding part. Okay, so I think from next session onwards it will be like a theory and coding part. So let's see, it will go in that way. Okay, so yeah guys, without wasting any time, just we will jump into this session. So this session is all about like introducing you guys to supervised learning. Okay, introduction to supervised learning. Supervised learning is a fundamental concept in machine learning. It's powerful tool for making prediction and gaining insight from data. Okay, so actually I will say this supervised learning is what which is like a normal, very normal thing, how we learn. Okay, how a human being learn. So in a beginning stage, I will say. Okay, so that is what a supervised learning I will tell. So and there is one more thing like called as a unsupervised learning. I will say once we are mastered with something, we will learn in that manner only. But we should not learn in like that manner. But like there is one more method that is called as unsupervised learning. Okay, so supervised learning is how we are in an early stage of learning. Okay, we will be giving, yeah, these are the things that we are having and you need to these things, you need to learn these things, like that we will be having. Okay, so yeah, so that is what supervised learning. And let's see in-depth concept of this in the upcoming slides. So yeah, that's what about the introduction to supervised learning. Yes sir, over to you.
Yes. So, introduction to supervised learning, guys, we have to first of all go and watch all the sessions 5 to 10 times and absorb the information, digest the information, and apply the information. Do all the assignments previous, and then come to this session. So, also subscribe to our channels and also press the bell icon so that you will get notification. So, let us start. So, introduction to supervised learning. Supervised learning is where, see, if you see the word supervised, it is some kind of supervision is put on machine learning. So, what is that? So, that would be like you have to, your your output is already predefined and your data is labeled. Okay, that is the main axiom, main premise of the super. Something is supervised. So somebody is there, they have asked you, ask the machine learning model that you have to perform this way, and that is the labeled, that is the outcome is already predefined, and also data is labeled. It is already given in a labeled way. So it is a powerful tool to make predictions and gain insights from the data. So both unsupervised and supervised models are same, but the supervised is wherein output is already defined, the objective function, and also data is labeled. And unsupervised, where data is not labeled and output is not defined. so machine will do. That is the only difference between supervised and unsupervised machine learning. So let's move to the other slide.
Yeah, sure. Moving on. Okay, now we will see the definition. Okay, guys. So defining supervised learning. In supervised learning, the algorithm learns from the labeled data, meaning each data point has its corresponding output or a label. The goal is to train the algorithm to predict the output for a new unseen data. Okay, I will say the same example which I am just saying for the past two like past two sessions of supervised learning. So that's the reason we are just asking you guys to just go through all the previous session videos so you guys can have a better understanding of what we are telling. Okay, so yeah, so what is meant by supervised learning? Just consider we are having a machine. Okay, we're gonna train our machine in a way using the labeled data. That means I'm having an apple. Okay, I will say if its color is red and if it is in the shape of a circle, it is an apple. Okay, learn it. I will give it to the machine. And I will have a banana and I will say the color of the banana, that is the color of this is yellow and it is in a not in a circle shape. Okay, learn it. Like that, if I give, that is together with the features, that is shape and color is a feature, together with the label, apple and banana are label, and I am training the model. This is called as supervised learning. Okay, hope you guys can understand. Okay, let's have a look into the PPT what I am having. Okay, yeah, labeled data. Each data point is associated with the known data, known output. Right? We are having a feature and we know the output, providing the algorithm with guidance that we are guiding. Okay, in the early stages of our life, our teachers will be guiding us, right? After that only we will be, after reaching some step, we can just learn by ourselves by looking into the books. Okay, so this supervised learning is guiding the machine to predict the output with labeled data. Next, prediction. The trained model predicts the output for new data based on the pattern learned from the labeled data. Okay, if you give the new data, now you can predict. Okay, because like now the machine know. Okay, if it is in a red color and if it is in a circle shape, then it will blindly say it is an apple. Okay, because we have trained our model that way, right? So that is what the definition of supervised learning. We will give the labeled data for the machine to train, and based on the label data and it training purpose, it will just go and look into the unseen data and it will predict based on the labeled data that it has been trained. Okay, hope you guys have understand this. Yes sir, over to you.
Yes. So see, definition says that the algorithm learns from the data, which is like output. The output is already defined, already mentioned that you have to do this way, that way, as like Raja has given example, like your teacher will guide you how to study, what is the syllabus. So everything, like the syllabus data is already labeled and output is defined that you will once you perform all these exercises, you come daily to class, you do homework, so you will achieve an objective. So that's a good example. And the here, if we see, algorithm learns from the label data, meaning that each data point has corresponding output, okay, or label. The goal is to train the algorithm predict outputs for new unseen data. So again, here the goal is to predict output for unseen data. Okay. So in unsupervised learning also, you have to provide insights, prediction, and for the unseen data. The ultimate goal of machine learning, supervised, unsupervised, or reinforcement is, guys, to look for insights and look for unseen data and the patterns. That is the ultimate goal of this. Otherwise, if we had capability as human beings, then we don't need these machine learning algorithms or computers and stuff. Okay, so they are at high compute power, so they can predict all these things. So label data, each data point is associated with known output. So output is already defined, provide the algorithm with guidance. So the actual thing is that we know the output, but we don't know the unseen data. We don't know the unseen insights and patterns. That is what we need these algorithms, these supervised learning. So prediction is trained algorithm predicts output for a new data. So this is very tricky to understand, guys, here. Because when you say, okay, output is already defined, then why we need prediction? So that can be a contradictory question. But here it is like, so prediction, trained algorithm predicts outputs for new data based on the output defined, guys, which is already labeled, right? Okay, so uh, based on the patterns learned from the label data. So here it is again little tricky. So sometimes people might confuse it. Oh, if outcome is already defined, then why we need machine learning to learn, right? So some people might think that way. I'm just clarifying. So the guys here, it's a very simple thing that the patterns learned from labeled data, then it will look for new data. But in unsupervised learning, there is nothing labeled. It will learn itself. The patterns, it will learn itself. There is no labeled data and there is no output defined. So it is in the, like, it is going to explore, I would say. Like, first time you're going to Mars, okay? And you have to explore. Nothing. Nobody has any form of knowledge, no information. And then their unsupervised learning will help. And suppose we've gone to Mars 3, 4 times. Now we have some kind of labeled data and we have output. Then supervised machine learning will work, and places where we want to explore about Mars, so we can send a rover and it can go and do unsupervised and supervised. So it depends, guys, what kind of data you have. Is it labeled? Output is already defined. So it depends which machine learning you will use as per data characteristics and objective function of your problem statement. Let's move to the other slide.
Yeah, sure, sir. So moving on, we're gonna see what are the types of supervised learning we are having. Okay, supervised learning is broadly classified into two categories. One is regression, another one is classification. Guys, I will say it is a, I will say traditional approaches of machine learning. Okay, in supervised learning, one is regression, another one is classification. Regression, it predicts a continuous value such as house price or stock price. Okay, like consider we are having something like in order to predict the house price, we will be having number of floors, area of the house, number of bedrooms, number of kitchens, like those things we will be having, and we will be predicting the house value. How will be the house value? It will be like a continuous value, that is 1 lakhs plus 1 lakh 50,000, 5 lakhs, like that. In something like a continuous values, it will be like a values. Okay, whereas classification categorize the data into predefined classes such as spam detection and image recognition. Consider we are having, like, I will say, in the keypad, right? In if we just dial for someone, we will be having keys from 0 to 9, right? So in order to classify that, we will go for the classification algorithm because it has a distinct values, that is categorical values. It will be like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and there will be asterisk and ash. Like one is star, another one is asterisk. Okay, so like that. If we are having a distinct values of categories, then it is called as a classification. If we are having something like a continuous value, then it is called as a regression problem. Both has different tasks to do, but they are supervised learning algorithm. They confirm that the supervised learning algorithm. Okay, that like this is a simple explanation. Whenever we are having a continuous value, we will go for a regression problem. Whenever we are having a distinct value, that is like a categorical value, we will go for the classification algorithm. Hope you guys have understand. Yes, sir, over to you.
Yes, so types of supervised learning, guys. One is regression and the other one is classification. So regression, so don't go by words, guys. So they look like very jargons, like, Just go to understand the meaning, the meta meaning of the definition and the words. Okay. Regression is just predicting continuous value such as house price or stock price. So I'll tell you, I have given this example a lot of times. I want to set up a coffee shop and I want to predict my best optimal optimizing price for my coffee. So I'll test different prices, okay, so that I'll have the best price, and also I'll give value to customers. So it's like simple. I have to give value to my customers for the coffee. So then and only I'll be profitable. It's very clear, guys. Price and quality. The quality means value. That they are always, if you are able to manage quality and value, quality and price of any product in the world, and you give optimal, you will be successful. You are the best business person, because and that is what I had to see to make my coffee shop a successful brand. So I had to predict continuous value. Continuous value, why? Because continuously people will come and drink the coffee, right? So it's not a one day, every day, continuous thing. So I have to, whenever you approach a problem, you see is it continuous or is it categorical? Is it, what is it? Is it discrete? Is it, what is it? Is it time series problem? Is it, so you have to understand problems nature. Is it occurring random times? Is it continuous? Is it discrete? Is it, what is it? So nature of the problem. Always whenever you are approaching any project, understand nature of the problem so that you will be able to define well, then select right models, right algorithms. According to that, you will, I think you will do good. The main thing is people don't understand nature of the problem. What is the nature? What is the cause? Is it what how it looks like? Is it good? Is it tall? Is it small? Is it, what color is it? Is it fat? Is it lean? I'm just giving example, guys. So you have to see 360-degree nature of the problem. And this I'm giving in, like, based on my 15 years of experience, guys. So that only will come, that kind of consciousness, when you deal with lot of problems. And then you understand that, oh, this nature, that nature, okay? Suppose you are designing a Mars rover. Once you start designing and you start testing, you will understand what kind of conditions are there in Mars, right? And then you have to design and how I will collect data. So there it will be a different, first of all, for collecting data, you have to make big billions of dollars a project. So that's a different thing. So each problem will have its nature. Always understand the nature of the problem. Okay. Then predicting continuous values such as house price or stock price. So I have given example. Classification. It, see, again, classification, we use classification supervised learning into categorical data, which is like predicting like data into predefined classes like spam detection, image recognition, because we know, um, so we know these kind. And I'll tell you, guys, even in classification there are continuous problem, because see, I'll tell you, you might think, oh, I have chosen classification because it is a categorical problem. By nature, again, if you understand, okay, continuously people are finding new ways to spam and building new ways. They will put dot, they will change the spelling, they will, like, in suppose spam, like free is a word which is like used, a lot of spammers, they will use free so that people get attracted, right? So free, they will change it, they will make it FRE, no, FRFRE only. They will remove one word. So they will always innovate, always come up with creative ways to spam. You know, now if you ask me, oh, is it categorical? It is categorical, but it is continuous also, guys, because continuously evolving. People are finding new ways. So you have designed an algorithm for spamming, where is it spam or not, but they are evolving. They are building new techniques. So you need to understand that either you need to create a new kind of algorithm which is like classification continuous. I'm giving ideas, guys, because when you are in data science, AI, ML, you also can design an algorithm. It's not a rocket science. You just need to learn how to design algorithm. You guys can design algorithm. So I'm going beyond regression and classification, guys. Food for thought. Okay, just understand these terminologies. We are going into deep meta level, guys, and go beyond the surface level meaning, okay, and go and deep have a deep thinking about it, okay. And let's move to the other slide.
Yeah, sure, sir. Okay. Yeah. So moving on, guys. Now we're gonna see something like we have seen what is regression, what is classification. Now we're gonna see the difference. Okay. Now you guys can get a better understanding. Okay. So regression and classification are two distinct approach, as we guys are saying, each tackling different types of prediction problems. Okay. Guys, make sure like you understand the regression and classifications definition, which both are comes under the supervised learning. Okay. Now let's see the difference. Regression and classification. Regression means it's gonna predict the continuous values such as stock price or temperature. Continuous value. Whereas for classification, it categorizes the data into predefined classes such as spam or not spam. Okay. Regression is a continuous value, whereas classification is a categorical value. Then this algorithm used like uh, linear regression, polynomial regression, and something like support vector regression, decision tree regression, something like a random forest regression, multiple linear regression, different things are there. Whereas for classification, we are having something like um, logistic regression, and then we are having something called decision trees, support vector mission. That is classification. We are for regression, there is support vector regression. For classification, we are having support vector mission or support vector classification. Okay, decision tree classifier. So all the models within supervised learning will support most of the models. Okay, it supports both regression and classification because like it's a simple change, right? And you guys doesn't believe it. Okay, we from the starting of this session we are saying that data science is a probability. We cannot able to judge this is exactly what happens. We can say only optimal solution to it. Okay, that's the reason. Okay, keep in mind only thing in mind, regression means a continuous value, classification means it's a discrete value, that is categorical value. And I will say one small thing, if you guys are able to understand, just understand it. Okay, in the model. Okay, so because like it's a high level, I will say. Okay, because that's the reason I'm just asking you guys. If you guys able to understand, just understand. If you guys doesn't understand, just ping in the comment. I will try to explain it in a more easier manner. Okay, in regression we will be having a continuous value, right? But in classification we will be having distributive, that is 0 or 1. Okay, consider we are having a value in the regression called as 0.7. That is a value from a regression. Can I show the same thing in classification? No, right? 0.7 will be not there. It should be like either 0 or 1 and something, like something else. Spam or not spam, animal or not, human being or not, like that. Consider it is 0 or 1. Now I'm gonna make a threshold in regression to make a regression problem to classification. In regression, I am having a value of 0.7. Now I need to make it as a classification. Now I can make it, I can fix a condition. If a value is greater than 0.5, it is 1. Otherwise, it is 0. Now, based on the regression value, it is 0.7, which is greater than 0.5. So now the classification is 1. Guys, try to understand this concept so that you guys can have a better clarity of why I'm saying this supervised learning is a combination of regression one and the classification one. I hope like I have explained you perfectly. Okay, regression problem can be converted into a classification problem, right? They are interdependable, right? They are reversible. Okay, so I'm just saying why they are related. to this supervised learning. Okay, so yeah, that's what all about this classification, like this versus, like a difference, and then how they are related. Okay, so yeah, sir, over to you.
Yes. So, see, guys, the regression versus classification. So, again, one is predicts continuous values like stock price, temperature. It's these are continuous, na? Temperature never like it's not like today it is temperature, tomorrow it is not. Stock price is always going up, down, huh? That's why. So that is the nature of problem, huh? So categorical is classified, but still continuously evolving. That consciousness you need to have. Categorical also is continuously evolving, but not that fast, like stock price uh, or temperature, right? But stock price and temperature has a nature of changing. But here, classified, they are like they evolve with time. But that consciousness you need to have. Okay. Then we use algorithms like linear regression and regression, polynomial regression. So linear regression is like line regression. Line. Linear is word comes from line. It's line, straight regression. Polynomial is where there are different multiple. Poly means multiple. Nomial, huh? Multiple dimensions. When you have multiple dimensions, you use polynomial regression, and then or you use support vector regression, because that's also will help. Like for polynomial, you have different vectors in the plane, hyperplane and stuff. So this will help you to polynomial and multiple. When you have multiple, when you have linear line, matlab it's like single straight, then you use linear regression. Simple, huh? Then classification, it it is a categorical data which like is predefined classes such as spam and not spam. Okay, zero or one, whatever. So we do it in zero and one binary. Okay, machine language. But if you see, machine understands in binary only. So it is just for our just human beings to understand. Uses the algorithms which we use is logistic regression and decision trees, sport vector machines. Okay, so if you see sport vector machines also, because there are like there is some nature in classification also which is like continuous. So that is why we use mix of both. Okay, so decision trees also, they have their own limitations. Logistic regression has its own limitation. Sport vector machines are very powerful. It's a very powerful algorithm, guys, for for categorical, and I will say uh, like if you see sport vector regression in regression, right? But in sport vector machine in classification also. So because of multiple dimensions in data and some kind of continuity, continuous and predicting that continuous something coming up, some insights will come, some prediction. So we use sport vector machines in classification. So we'll go deep into all these things, guys. This is like we are going to meta level. We'll go deep meta level in like in future sessions. So you'll understand what we are talking, why these terminologies have been classified. This is like if you have an overview, keeping regression and classification into different brackets, supervised, unsupervised, reinforcement. This is also kind of classification of knowledge, so that we can specifically go deep into understanding the problem and using specific algorithms and models to solve the problems. Okay, so let's move to the other slide.
Yeah, sure, sir. Yeah. So, guys, yeah, we will pass here. We will continue the remaining things in the next session. Hope, like I'm very much interested, guys, because like we have stepped into the concept of machine learning, where like we are now seeing what are the types we are having in like supervised learning, and inside that we are seeing what are the types in it. Okay, now we have the types of supervised learning, right? We are having regression and then classification. Inside regression, now we have seen these algorithms, right? Example algorithms, linear regression, polynomial regression, support vector regression, like those things. In classification also we are having logistic regression, support vector machine, decision tree. There are more things, guys. We are gonna learn each and everything in a bitwise manner, bit by bit. Okay, I will say in a serious way, like we're gonna see in a depth-wise manner. Okay, so yeah, guys, that's all about this session. Hope you guys have enjoyed this session. If you guys have any doubts, just ping in the comment. We are here to help you. Okay, so yeah, until next session, bye guys, take care.
So, guys, go and watch all the sessions 5 to 10 times, do reinforced learning, and also absorb the information, digest the information, and apply the information. Do all the assignments. Write in the comment section, give us feedback. Each session will be improving, so continuously improvement is the key for success, guys. So give us feedback, we'll be continuously improving. Also write in the comment section what have you learned, how you're going to apply, and what is your long-term objective of your career. So keep learning with patience, consistency, persistency, and watch all the session 5 to 10 times, and subscribe to our channels, and also press the bell icon so that you will get notification for each session. Thanks a lot. See you in the other session.
Yeah, guys, thank you.